Hello, Dr. Ron England coming to you to, wait, you ought to get out of the way there. Dr. Ron England coming to you from Daytona State College, and today we're going to talk about aggregation. Okay, I'm going to put Yoda away here, and we're going to talk a little bit about aggregation in databases. I thought we'd have a little bit of fun with this one, so I'm going to work a little bit with this food database, and we're going to play a little bit with this. Aggregation in databases. Aggregation are simply functions that allow you to do very powerful and easy things very quickly using SQL. So one of the aggregations, if you've ever done anything in SQL, you've probably been familiar with this aggregate function called count. And if I execute this, I will see that the database I'm looking at has 2014 rows. Well, let's look at the database I'm looking at here, because that's going to make a difference to the other functions that I'm going to do here. I have this database, and it's basically a database of foods. I've got it off the usdata.gov website. And I'm looking here at the portion display name. That's what I'm going to do my aggregate function based on that, but I could do it on many other things here. And what I've noticed is that the foods often have a display name for specific, let's say we're looking at ice cream rich. And if you look at rich ice cream, you'll see that the display, the name for the quantity that you have with that would typically be a cup. So a cup of ice cream, one portion amount, cup of ice cream would be simply a basic serving. That's if you are capable of eating one cup of ice cream at a time. So what I want to do with this, I'm going to close this now, is I'm going to look at those display names and see if there's actually any relationship to those and the amount of calories you see in this. So here's my query. Portion display name is actually going to be displayed, and I'm going to count how many times that portion display name is used. I'm going to call that the number. So I'm going to use this function here, count. And then I'm going to average the calories. What this will do is it will average the calories for each display name. Now to do that, I actually have to tell it to do this. So since I'm averaging the calories out based on portion display name, I'm going to group this by the portion display name. Okay, I'm going to take each average of the calories for each portion display name and show you what those calories are, and then I'm going to order them by this. I'm going to order them by the number of times that portion display name is used. So if I take this query and I go ahead and I execute it, I can see here that cup is used 445 times. And if you have a cup of something, on average, you're going to have about 139.7 calories. That's that number right there. So anytime you get a cup of something, it's going to be about 139.7. Now, of course, it means if you're doing ice cream versus water, it might be totally different. Much better to eat a tablespoon of something. That's used 71 times in the database, but look, if you eat a tablespoon, you only get 47 calories of it. Okay? Well, yeah, obviously the food that you take into account here will be kind of important here. But let's do this. Let's actually, instead of ordering it by the number of times that display name is used, let's order it by the calories. And let's rerun that query, okay, and you can kind of hopefully see how this whole query pans out. Let's rerun that query, and now, here's what you don't want to have. An order of 10 halves. Ooh, it's only used once, but it's got 1,667 calories in this. Of course, if your portion is a duck half, that's 1,283.5 calories. Now, hopefully you can actually see how the database is taking this information, looking at the individual portion display names, grouping them, and averaging out the calories. In the case of these specific ones here, like the 16-ounce pie Hungry Man at 976 calories, well, it's only in the database one time, so it's used as a portion display name for that one specific thing. Or in this case, a hen. The hen only is 792 calories there. So, and I actually go back and say, what would be kind of interesting to see what exactly has the portion display name of one hen. We can do that relatively straightforward. Let's just say select star, okay, from this, okay, where portion display name equals, in this case, and it's lowercase hen. So let's execute this query here and see what we get. Obviously, the roasted Cornish game hen which has 2 in a package, okay? And each hen is going to give you that number of calories because that's your portion amount. So, wow, kind of interesting stuff there. But let's move onwards to some other types of aggregate functions. And in this one, I'm going to move to a different database here. I'm going to use my crime database. I'll show you some different types of aggregation here. And by now, I think you should be fairly familiar with, okay, well, let's look at like what's the total number of robberies that you have in this database, which is 25,410. Now, what we can do is we want to look at that in different ways. And let's say we look at the average number of robberies we have per city, which is 84.9, roughly. The standard deviation, that's relatively straightforward to do, 278.9, which actually tells you that it's a really high standard deviation. And let's say, you know what, I'm only interested in cities that have a population of over 1,000. I can do that very easily by executing this query. And as you look here, the average of populations over 1,000, well, I have 90, where the average of all the cities, in this case, was 85. So population over 1,000, as you would probably expect, has more of these. There's some other things that we can do with that. I'm going to move down to this query, which is going to use another function called n-tile. And n-tile, you might have heard the term quartile. Okay, a quartile means you split it up into 4 pieces, and you put a quarter in the one piece, a quarter in another piece, a quarter in the third piece, and a quarter in the other one. Well, n-tile is a function that lets you split it up into however many pieces you want. And we want to use this function. Okay, and the reason we want to use this function is let's go ahead and let's look at the robberies in the cities blocked off by this n-tile. So let's first run the query here. I've written the query already. And what it's going to tell you here is that Jacksonville ranks in, for robberies, ranks in the first quartile. If I scroll down, I can see that there's a second quartile, a third quartile, and a fourth quartile. Some of these have no robberies at all. So what you're really doing is you're saying that the cities with the most robberies are going to rank into this one n-tile, in this case of 4. Well, that's kind of an interesting type of way to look at that. What would we want to see the average number on those? Well, we could do that. Okay, let's go ahead and put average of the robberies into this here. Let's see if we can execute that. Now, this is one of the things that's going to be very important because I want to actually show this to you. Column cities.city is invalid in the select because it does not contain either an aggregate or a group by clause. Okay, now what's happening here is I've gone ahead and I've added in this average here, but what I haven't told it is, well, how is this going to fit? I've got the city here. Well, the cities necessarily fit within the n-tiles, and this was great when I was trying to show you each individual city and each individual robbery, but in this case, I actually just want to show you the average for the quartiles. Well, to do that, I'm actually going to have to take these 2 fields out to do that, okay, because it's not in that order by. Now, let's go ahead and run this again, okay, and now, let's look at this. The robbery itself, the n-tiles of what we're looking at here, specifically, you're looking at 4 different n-tiles which are ordered by the robbery in this case. But what I want to see here is not the actual n-tile, and this is not even the right type of function to use to do this. Okay, the n-tile, if you look at what it did, and let's go backwards one because I'm going to actually show you how to do this correctly. Let's go back and let's put in the city and the robbery here. Okay. What does the n-tile actually do? Well, if you look at this, the n-tile, comma, let's add that. Okay, now if you look at this, what does it do? Got to take another comma out. And you can see, it's very quick at looking at the errors that you get and actually making a solution. What does it do? It adds a column. Okay, it actually returns a specific column which gives you what n-tile, what quartile, in this case, the city and the robbery fall in. Well, if you think about that, looking at those averages in this, and what you're doing with this quartile, doesn't make any sense. okay, because you're actually looking at, I want to assign a quartile, a rank quartile, or rank intile to those specific cities. And if I look down here at the results, I can see that I've done that. Well, let's look a little bit more detail at some of the other things that we can do here. And in this case, I'm going to do something different here. I've actually quartiled them out. Now let's look at this in terms of putting together what is the actual rank of each individual city. So let's execute that. Now, again, in this case, Jacksonville did show up as the robbery capital here. But if you look at this now, you'll also see that it's ranked number 1. The quartile, or the intile, wouldn't tell us where it was specifically ranked, okay? But in this case, I actually have to assign a rank to these. So that rank over this as rank is going to show you the rank of each individual city as you go through there. And that's going to be numbered. And as I want you to show here that here where I've got Haines City with a 90 and Wellington with a 90, okay, then it jumps to 92. Okay, and I got a few of these with 94. Okay, with a tied rank, it goes ahead and assigns an equal rank to each of those, but then moves to the next incremental number in the rank less the number of times you've seen it there. Well, what I've shown you here is hopefully enough information to be able to start working directly with how to do aggregate-based functions. We've looked specifically at the rank functions, the group by, the order by, and the entile functions, and also some of the statistical functions that you can use in this. These are extremely powerful and allow you to get data very quickly with forming a simple SQL query to get stuff out. That's all for now. Good programming, and hope that you learned a lot through this and were able to see some pretty neat stuff. Thanks. Bye.